Good afternoon, everybody. Great, you can hear me this time, yeah? I've been talking for the last 2 minutes, but there we go. Good afternoon, everybody. Welcome to the FutureX Innovation stage. My name is Andy Cameron Smith. I'm the Editorial Director for Unlock Net Zero, which is a knowledge portal and events program which is focused on the practical reality of the net zero transition for both the UK housing and built environment sectors and the supply chain that supports them. So for this session this afternoon, over the next 90 minutes, we're going to hear from some leading practitioners on some of the key challenges we face to deliver decarbonisation across the built environment. I think we all understand the contributions that the built environment makes to the UK emissions target, and that we need to adapt and change how we operate in the future. So this afternoon, we're going to be looking at 4 key areas: the decarbonisation of heat, the reduction of carbon emissions from the use of concrete in actual buildings, the regeneration of nature in our urban planning design, and the introduction of low carbon technologies into the domestic home. So when you look at those topics, it really reinforces to me how we need to take a real whole systems approach to decarbonisation. It's impossible to operate in silos and in isolation, and we need to learn from each other, which makes a session like this afternoon all the more valuable to increase our learning across the way. So our format is that I'll be joined during this session by 4 different speakers. They'll all speak for around 20 minutes, and within that we'll find some time for some Q&A. So if you can just get some questions in, because what I always find with these kind of sessions, it's better if we turn it into a debate and a discussion rather than just a broadcast of views. So don't be shy, go and ask some questions. We'll have a roving mic going around afterwards. So if I could just introduce our first speaker, and we're going to start the session off with what I think is, and I don't want to scare you, Johan, but if we look at the whole net zero transition for the UK, the decarbonisation of heat is probably the biggest single challenge we face. So to discuss that and look at how we can go about it, please welcome to stage Johan du Plessis, who is the CEO and founder of Tepeo.
Thanks, Andy. I'm Johan. Hopefully you can all hear me okay. Feedback's not great here, but I think you can hear me. And thankfully, Andy has saved me some time because you've stolen my first slide. Actually, my second slide, which I'll come to in a sec. So a quick overview on Tepeo. We are a mission-driven company. I founded Tepeo 5 years ago, almost. And for the sole purpose of creating technologies to support the decarbonisation of heating, particularly with a domestic focus for now. So our ZEB, or a zero-emission boiler product that we've invented, is a simple zero-emission, low-cost product that enables customers to easily decouple and come off from gas or oil or LPG. We're working with a range of partners like OVO, Octopus, UKPN, the distribution network operator, and others. We've recently closed a big funding round. We're growing very quickly. We manufacture all of our products in the UK, just near Reading in Wokingham. And this year is about commercial and production scale. So I'll talk more about the product at the end. But I'm going to start a little bit on heat, and he's absolutely right. Heating is, I do believe, is the single biggest challenge we have to getting to net zero. Other sectors are decarbonising quite rapidly now. Some others, notably EVs. And heating is often not talked about. Increasingly it's talked about more, but it's been the elephant in the room for decades. And most people don't know that it's actually, for most people, it's the biggest proportion of their CO2 emissions. It's a massive market. There are 1.8 million boilers installed every year in this country. That's still today. 99% of the boilers that are replaced every year are replaced with more boilers. So we need to change that really rapidly. And I do think that there is a trajectory to be had, like the one on the right that we've seen with EVs. The question is when it starts. Like, when can we get this pickup happening? Because it's not happening yet. Heat pumps are brilliant. I would never knock heat pumps. I think they're a brilliant technology, and we should install millions and millions of them. The problem is that for millions of homes, they're not suitable for a variety of reasons. And a single technology view that has been taken over the last number of years is actually stalling the installation and rollout of heat pumps. And we need some other technologies, and we think that's where our technology fits. So electrification of heat, I think, is the way forward. We've seen the grid intensity dropping dramatically over the last 10 years. But heat pump sales are not really picking up. We're still at about 50,000 a year. And that is in spite of the RHI subsidy, which kicked off in 2014, and now the boiler upgrade scheme. And why is that happening? Why can we not get this traction that we need? There's another part to this. We need flexibility. And as we decarbonize the electricity system and we get more and more renewables on the grids, we have to be much smarter about the way we use electricity, because we're losing our ability to control the generation side. So we have to change the way we use it. And you can see here on the right, just in the last number of years, the amount that we're spending as a country annually just on the grid balancing mechanisms. So 1.3 billion pounds a year spent a couple of years ago, and it's gone up since then. We're curtailing wind to the tune of several £100 million a year. So that's stopping wind generation that we just can't accept onto the grid because we don't have the flexibility to use it. So, why is heating so difficult to decarbonise? The writing on this slide is too small, but hopefully you guys can get hold of the slides at a later date. But there are a few key reasons. I think it's a complex area. Every home is different. That's the first thing. There's been lack of clear government policy and underinvestment in our homes. And we are creating the environment where customers are getting confused because they're getting misled by many people in the sector, many people actually here today, unfortunately. So we've underinvested in our systems. We've got, a lot of us do not do any maintenance in our heating systems, so when it comes to trying to upgrade your system or improve it, you've got all this kind of debt effectively that you've built up because you've got sludge in your radiators and all this other stuff, which you have to clear out regardless of what source you're changing to. We've been talking a lot to the government recently. They are very on board with what we're doing. They want to take a more technology agnostic approach, but to date the policy direction has been confused. And I would still argue that with the carrot of hydrogen out there, which I think has some really major challenges, it is another thing that's creating this opportunity for confusion, mismessaging, etc. And training is a really big problem as well. So we have 200,000 gas boiler installers in this country and about 4,000 heat pump installers. So what do you think we're going to install more of? And that it's not really changing at any decent rate, and certainly not at the rate it needs to. I'm going to skip that slide, and I'm going to talk about what we do. So the ZEB is a plug-and-play boiler replacement. So it's a quick install. It's typically done in about a day now. We use existing gas boiler installers. We give them a sort of 3-hour familiarization course, but really it's quite simple. If you can install a gas boiler, you can install a ZEB. It works with the same heating system, so you don't change your underfloor heating or your radiators or your microbore, whatever you've got. And it works with the same thermostat. So whatever thermostat you've got, we can work with it. It charges at up to 9 kilowatts peak. It stores 40 kilowatt hours of thermal energy. So it's what we call a dry core thermal storage device. But it's actually the most energy dense form of energy storage you can buy. And it's storing that heat over the course of the day. And then we can extract that and put that directly into your central heating system whenever your thermostat calls for heat. So we're decoupling the consumption of electricity from the consumption of heat. And actually our units in the field are typically decoupling between 80 and 100% of their energy use, between the time that the electricity is used and the time that the heating is used. And I'll come to that in a second and why that's so important. Finally, we're doing a lot of stuff on board, like monitoring the electricity consumption, monitoring the grid frequency, which allows us to do some other really cool things that I'll talk about in a moment. Importantly, every device is then internet connected. So we are monitoring, or the ZEB is monitoring the performance of your heating system. It's then using some machine learning in the cloud to forecast exactly how you are going to be needing heat over the next 24 or 48 hours. And that is fed into an optimization engine that's then taking account of your tariff, the carbon intensity on the electricity grid that you're part of on your distribution network, and all your personal preferences, like how carbon or cost conscious you are, and other things like how much extra storage you want to have available at any time. It then spits out a specific charging profile for your individual ZEB based on your own circumstances. And finally, the slightly more geeky bit, which I will touch on very quickly, every ZEB then becomes part of a fleet. And so what we can do with our fleets of ZEBs is we have effectively what we think of as a distributed grid-scale storage asset. So we can do things like grid balancing services, frequency response. So back to what I started with about the high balancing mechanism costs for the electricity grid, we can support that whole process. On the left, you can't see again because it's too small, but these are graphs of frequency plots that are being measured by our actual ZEBs in the field, and they're picking up grid-scale events like a nuclear plant tripping or an interconnected tripping to the continent, and actually able to respond in sub-second timeframes to then support the local infrastructure. And all of this is part of the broader energy system transition to enable us to do this at lower cost and faster. So that is what I was going to say. That was about 15 minutes, I think. So if there are any questions, I'd love to take them. Otherwise, I'll skip back a few slides and talk some more.
Yeah, we've got a roving mic, so if it'll just come to you, if you just say your name and what your question, please.
Hi, I'm Steve. When you retrofit one of these into an existing property, do you need to oversize your radiators like you would with an air source heat pump? Or?
No, absolutely not. So we don't change the infrastructure in your property. So on the app, which you get access to, you can set your flow temperature up to 80 degrees. So the whole, one of the big USPs here is that it's not necessarily for everyone to completely retrofit their property and to change radiator sizes. So yes, you don't need to do that.
Okay, thank you.
I should say though, that doesn't make this for every property, and there is still considerations to be done about the heat loss in your property. It is sized for the current model. Is sized for the median home and below. So if you're using up to, you probably don't know, but if you use about 12,000 kilowatt hours of gas or the equivalent of oil or less a year, then you're probably in the right bracket. That would be up to about a 3-bed semi-detached kind of size in terms of heat demand.
Sorry, Stephen here as well. How does it work? I don't get how it's a gas boiler. You're going to put something on it, and that's going to decarbonise, and it's going to reduce energy.
No, so I clearly didn't explain that very well. I'm sorry. The first thing we do is cap your gas supply. So it's not a gas boiler. So we cap the gas supply. We connect this to the electricity supply. We take out your flue. In my house, I replaced the hole where the flue was with a nice access point for internet outside, but you can block it up or do something else with it. You don't need the hole in the wall. And in fact, that means that the ZEB can be installed in a variety of different places in your house. It doesn't have to be installed on an outside wall. In my house, it's actually installed in the middle of the house under the stairs because there is no flue. So it is electricity based. So what that means in terms of the emissions, there are no tailpipe emissions because there's no exhaust. There are embedded emissions in the electricity we use. So what we're doing with the product is we are able to use, one, we're using electricity, which already is less carbon intensive than gas, but actually on an intraday basis, the carbon intensity of the grid varies dramatically depending on what types of generation sources are on the grid at that time. So we monitor that as well, and as a consumer, you can say that you're particularly carbon conscious, and we will just actually pick the times of day to charge the device based on the carbon intensity at the time, or some combination of that and the price, because for most people cost is a consideration as well. So that depends then on the tariff that you're on.
Is it an electric heater?
It's effectively a direct electric. It's effectively a direct electric boiler, but it's also what you would technically call a dry core thermal storage boiler. Yeah. Yeah.
Have we got any more questions? Yeah, one at the back, please.
Hi, I'm Anthony. I'm just doing a retrofit of a Victorian building, and I was very surprised to learn that to get a decent EPC rating, I had to put a gas boiler in. And I just wondered if your system would actually assist. They don't seem to take account of the carbon when doing EPCs, which surprised me.
It is very surprising, yes. In fact, I was in Westminster yesterday, we were talking about this exact problem. Yeah, come and talk to us. So SAP, which is the standard assessment procedure that was used as the basis of the EPC rating, is completely broken. It's not just me saying this. This is anyone who works in the industry would agree. Basically, it is really outdated. It uses very old emissions factors. It's supposed to have been updated for years now. The new build version has come out, the RD SAP, which is the renovation one, or for retrofit, hasn't been updated. So it has historically always penalised electrical heating, anything electric, in fact. That is going to change, but it's like pulling teeth. It's really, really slow. And there's a whole new version of SAP that's being worked on now called SAP 11. Well, actually, I don't think you're allowed to call it SAP 11, but it's the next version of SAP, which in theory comes into play in 2025. But we're saying this exactly to ministers that, unless we have, this is one of the policy things that's actually pushing against, the regulations is pushing against the policy that the government is trying to implement. We're trying to decarbonise heating, and yet the regulations are telling people to use gas. It's nuts. It is completely bonkers.
I think we've got time for just one very quick final question here.
Okay, David, just to echo that point, it will change, it has to change, because I put a heat pump in and my EPC actually got worse. So same situation, but it was still the right thing to do. But from your perspective, are you saying that you don't need to retrofit your house? So fabric first is usually the approach that most people would take, so use less energy rather than change the source. What's your view on that?
I wouldn't say that it has to be fabric first, because I think that puts people off. I would agree with you. Yes, if you can afford, if you have the time, if you can, reduce the total energy consumption of your home, that's a great thing to do. But we have people that come to us and they just say, for whatever reason, I just want a ZEB. I don't actually want to spend my money on insulating right now, and I don't think people should be put off on that basis. But yeah, we should be. I mean, our housing stock's leaky. We need to insulate it much better. For larger homes, I think you are going to struggle to get away from the COP you can get with a heat pump, and you're probably going to need some sort of hybrid system with a ZEB, which is what we're doing in some homes where we have hybrid systems running. And we have got a stand just over there, so if you have other questions, do come and find me or some of my team, M44.
That's what I was just about to say.
Okay.
So, excuse me. So a very complex subject there, decarbonisation of heat. We've touched a number of points there, interesting discussions. I think we could have talked for an hour and a half about EPCs alone. But would you just thank Johan for his time? And as I say, any more questions, go and find him on the tepeo stand. Thank you.
Thank you.
Right, good afternoon. Welcome back. So we've done decarbonisation of heat. Done that in 15, 20 minutes. Now we're going to look at concrete and how we decarbonise that. No pressure here. But please welcome to the stage to discuss how we reduce emissions from the concrete that is used in the construction projects. I'd like to introduce Ian Clements.
Thank you, Andy. Can you hear me? I trust you can all hear me okay. Good afternoon, everyone, and thank you for coming. As Andy just mentioned, I'm Ian Clements. I'm the Commercial Director for Hanson UK. Hanson UK are a major manufacturer of concrete, cement, aggregates and asphalt here in the UK, and we're part of the Heidelberg Materials Group globally. And today I'm going to talk to you particularly around the challenges facing concrete manufacturers all over the world in decarbonisation, and then touch on the pioneering and exciting developments we've made here in the UK to lead that race to carbon zero. Okay, so first, just a little bit about the concrete market. It may surprise some of you to hear that concrete is the second most used material in the world, second only to water. The Global Cement and Concrete Association estimate that 14 billion cubic metres of concrete were produced in 2020. Now that's despite the pandemic, and that's a figure that's more than doubled in the last 20 years. If you look here in the UK, you don't have to look very far to find concrete. It's used extensively across our industry, whether it's in housing, schools, hospitals, bridges, tunnels, you name it. Generally, construction projects have some requirement for concrete somewhere, even if it's just foundations. And if you look at the larger end of the scale on screen, we've got Hinkley Point C, nuclear reactors being built there, a project that we're heavily involved with over 1 million cubic meters going into that project already, and it only being just over halfway through. And you've got HS2, another huge project in the UK. Latest estimate on that one is about 5 to 6 million cubic meters. So demand globally is at an all-time high. But it's well documented that there is a lot of embodied carbon in concrete, particularly with traditional types of concrete. So that poses a real challenge to our industry, and it's one that we take very seriously. At Hanson UK, we are revolutionising what we do, and we're transforming the future by putting sustainability at the forefront of everything we do. And that's backed up by our parent company, Heidelberg Materials, who have signed the business ambition for 1.5 degrees C, and they've also signed up to the UN's race to net zero. So that's a clear indication of our intention in this field. So first, a little bit about why there's so much CO2 in concrete. Now, I don't know if you can all see the numbers on the screen there because it's a little bit small, so I'll talk you through it. But the pie chart on screen represents 1 cubic metre of a fairly typical concrete, a C35, made with CEM1. And you'll see there's 245 kilograms of CO2, embodied CO2 in that cubic metre. And you'll see also there's a very large orange segment of that pie. That orange segment is the CEM1. It's 87% of the embodied CO2 comes from the cement that's used to manufacture the concrete. The other 13% is made up of a mixture of haulage, aggregates, chemical admixtures, and our general operations. And we're doing everything we can as a company to tackle that. As most are, we're switching to electric vehicles, we're putting solar panels in our quarries, we're even switching our offices to green tariff energy. Everything you would expect a conscientious company trying to get to net zero, we are doing. But obviously that's only 13% of the overall problem. And the real challenge comes from the CEM1, the 87%. And actually, if I'd chosen a stronger concrete, like a C60 for example, that percentage would be over 90%. So why is there so much CO2 in cement? Well, it's from the manufacturing process. What we do is we take calcium carbonate and we heat it to extreme temperatures, as much as 1500 degrees C. And what that causes is the breakdown of the material, and it splits into calcium oxide and carbon dioxide, which is emitted into the atmosphere. Now those process emissions, and that process is called calcination by the way, those process emissions account for 68% of the total CO2 linked to cement. The other 32% come from the fuel being burnt in the kilns to get to 1500 degrees. So what are we doing at Hanson to tackle this? Well, we're actually involved in a number of industry-leading projects. The first at our Padeswood plant in the northwest. Padeswood is part of a consortium called the HyNet Consortium, and it will see us deliver the UK's first carbon capture and storage facility at a cement works. We're aiming for that hopefully to be live about 2027, and when it goes live it will capture up to 800,000 tonnes of CO2 per annum. And that will be piped out to the sea for storage about 1 kilometre below the seabed in large voids that have been created over many decades from the extraction of natural gas. And that gives us a safe and tried and tested way of storing the CO2. The second exciting project was last year. We ran a successful trial at our Ribblesdale cement works, and we switched the fuel across to hydrogen. Now hydrogen is a clean gas when it's burnt. The only byproduct from burning hydrogen is water. So we completely eliminated the fuel emission element while producing cement for a number of hours. It was a very successful trial. The kiln ran very efficiently. We would have loved to have left it on hydrogen permanently, but obviously hydrogen at the moment is a very expensive gas as it stands currently. And it's not as readily available for us to use permanently as we stand today. But we're tracking that very carefully, and as the cost of fossil fuels increases and the cost of hydrogen comes down and the availability improves, in time we'll have a solution, and we've already proved that that can be done. So those two give us an exciting future of moving towards net zero. That's what we have planned. And actually, if you look globally at our parent company, Heidelberg Materials, they're actually moving at even more pace. We have a number of carbon capture sites earmarked around the globe, and many underway. And actually, we stand to introduce the world's first at Brevik in Norway, which we hope will be live towards the end of next year. And here in the UK, we're watching that eagerly and looking forward to learning a lot from that project, because it will help us pave the way for the future here in the UK. So that was what we're doing in the medium to long term, but of course there's things we can do now to help reduce carbon. And in the last 12 months we've relaunched our EcoCrete range, and through using EcoCrete we're able to eliminate up to 85% of the CO2 compared to a traditional CEM 1 concrete. And we do this predominantly through using cement replacements such as GGBS and limestone. And whilst that's not a new idea, cement replacement's been around for many years. The innovation here has come from building and developing clever admixture technologies that help alter the performance of these concretes, because one of the key concerns and challenges we find on site are that cement replacements can cause the concrete to take a bit longer to set, which leads to longer finishing times, and of course time is money on site. So with these clever new admixture technologies, we're able to better adjust the practicalities on site, and we work very much in a collaborative approach with our customers, and make sure that as well as meeting the design requirements on site, we also take into account the practicalities and how that concrete needs to behave on site. We're also employing technology, and we've actually partnered with Geotech, who are the world's leading wireless concrete sensor manufacturer. Now again, these sensors, wireless sensors, have been around in concrete for some time now, but where we're using them to innovate around sustainability is by putting them in our EcoCretes, and rather than waiting for traditional tests, taking cubes, putting them in a laboratory and waiting 7 or 28 days before testing them for strength, by using these probes we're able to track the maturity of the concrete immediately after the pour. And within 2 to 3 days we can tell exactly how that concrete is behaving, and if it's slightly over-engineered and going to hit higher strengths than are required on site, we're able to strip out further cement, therefore reducing the CO2 and hitting the absolute optimal reduction while the construction phase is still continuing. So that's a very brief overview and high level of what we're doing. If you did want any more information on the carbon capture and storage, it's all available on our website, which is hanson.co.uk. On there you can also find a lot of literature. We have a net zero roadmap which sets out our plans for the next 3 decades to get us to completely net zero by 2050. We also have some ambitious and industry-leading targets for 2030 to bring forward some of our actions. We also have our EcoCrete brochure that's on there that can talk you through some of the products that we have available. And there's also a number of case studies. We've had great feedback on our EcoCrete range over the last 6-12 months with the new range, with the new admixtures. So we have some case studies available to give confidence when specifying these products. And also, in terms of getting that message out there and educating and so on around sustainability, we're holding a number of webinars. They're free to attend. They're called Let's Talk Sustainability. And in April, we will hold our 3rd event, which is open to all. It will be on the 26th of April. If you're interested in that, I'll be hanging around afterwards. Please drop by, give me your details, and we'll make sure you get an invite. But we'll also be putting that out on social media, LinkedIn, etc. And also, if you've got anything that you need help with in terms of specifications or anything like that, then please drop us an email to inquiries@hanson.com or come and have a chat afterwards, and we'll be happy to help. Okay, thank you. I'm going to open to any questions that anyone might have. Thank you.
A lot covered there, some really fascinating things. Really interesting to see you talk about carbon capture and storage. I think for a lot of people that's a bit of the holy grail of the net zero, so it's great to see that progressing. So we've got a bit of time left for questions, so please raise your hand, a microphone will come to you, and you can ask your question of Ian. If we're all feeling shy, oh no, thank you very much indeed, sir.
Hi there. Thanks for the talk. Is GGBS a part of EcoPact a long-term plan for you guys, or is it just a temporary solution until you can get the cement reduction on your production?
Ecocrete. That's okay.
Ecocrete.
Ecocrete. So we are constantly looking at other options and other replacements, etc. Obviously, Pagewood will be the first in the UK to make net zero carbon concrete, or cement, sorry, that will then be used in the concrete. But the other two plants elsewhere in the country will be a bit behind that. So we are, as well as long-term using GGBS, we are looking at other cement replacements as well. So that was just, what's happening in the future, but all the time we are looking for innovation and other options, We're investing a lot of money in the science and exploring all avenues,
Thank you.
But GGBS is here for, a good while to come.
Thank you. Have you got any more questions? Okay, I'm going to use Chair's prerogative to ask the question. So obviously it's quite a big transformational change for you as an organisation. How is that feeding through into the supply chain that works with you, and how do you get them to be ready to be net zero carbon neutral as well?
Okay, so we're working with our admixture suppliers, hauliers, etc. As I mentioned earlier, we're looking to move to electric vehicles. So on our own company vehicles, as well as cars, we're looking at the heavy fleet, etc. So pushing for electric there. But the admixtures, we're making sure that the packaging is reasonably sourced, it's recyclable, and we're doing everything we can. So we are talking to all of our suppliers to push for sustainability, and we're measuring that across the board.
And I think that's interesting because that's how it kind of feeds through the kind of chain and everything from those kind of companies.
Absolutely.
For that. Okay, do we have any more questions from anybody in the audience? Can we give you one more chance? Speak now or forever hold your peace. Okay, thank you. Well, please join me in thanking Ian. I'm sure he'll be around afterwards as well if anybody does have anything you want to ask in private. But thank you very much, Ian.
Absolutely, thank you.
Thank you very much for bearing with us while we're just waiting for everything to download. We're now going to move on and look at how we can design buildings that both reduce the environmental impact but also help to regenerate nature as well in our place-based design. So to talk us through that, I'm now going to hand over to Sebastian from A2M Architects. Sebastian.
Yes, thank you. As you're going to hear, I'm coming from Belgium, so with a little French accent, but I'm going to do my best. So in the coming 20 minutes, I'm going to show you that starting from a certain context in Belgium, we spread in different countries like in France, Luxembourg, and also in the US. So we are an architect practice coming from Brussels. Brussels is not only about chocolate and waffles and Smurf and whatever. It's also about the fact that it's the first region in the world ever where passive house has been voted. So the law came into effect 8 years ago. So today, whether you like it or not, in build, new build, in retrofit, whatever you do, you have to fulfill passive house. It means 90% reduction on your build. And this is for all kind of design, all kind of destination, no matter the scale, no matter who's going to ask, private, public. So this is where we are now. And you can see all kind of buildings went into it, even landmark, or as we can say, listed buildings. One of the things is, because we all committed to be CO2 neutral by 2050, of course there's no way we're going to get there, unless we're going to have no more oil within 10 years. But you see that for Brussels, that when that law came into effect 8 years ago, we have today already an impact. Because with the new build and retrofit, it has really a huge influence where CO2 is coming mainly from buildings in these kind of cities or regions. But nevertheless, to achieve a completely CO2 neutral country, we should have, even if we have a passive house law now, we should have 1 or 2 passive house building or residents non-stop from now, every hour, non-stop until 2050. And we're very far from that. And if you compare to, for example, to England, to London, for example, if I take the Great London, we should have we should build at minimum 15 to 20 dwellings to achieve passive house non-stop from now until 2050. And again, we are very far from there. even here. So you see, there's still a lot to do. But that's the case of all the countries all over Europe. So we can say that we are very bad, on a very bad situation. And one of the last thing, when we do buildings, we do a lot of simulation, dynamic simulation, to see how the building is going to behave in the future. So we take the worst case scenario of the IPCC. And the funny thing, which is not that funny, is that 2 years ago, not last year, but 2 years ago, we already had in our part of Europe the same climate that was foreseen for the worst case scenario in the IPCC, but who was foreseen for 2050. So you can imagine the one of last year is even worse. So this is just to say that if you want to do something, you just have to go beyond passive house. So we are, as I said, architects. We're close to 50 architects. We have three offices, one in Brussels, one in Lisbon, south of Europe, partly of north of Africa, and one in Brooklyn, in New York, I would say. This is for a project we have in Vancouver, in Canada, and some in the US. The only thing is that whatever we do is all about passive houses more than 15 years. So we decide, when the law came into effect in 2015, we decide, well, we should go beyond. So today it's not about can we reduce our impact, can we be low energy or whatever, it's to go even more beyond. And the question was, can we regenerate the environment? It means if you don't do the development, it's worse for the climate. So that's the idea. So of course, if we ask, it means that of course we can go there. And that it's possible because where you are in country or everyone puts on the market a passive house, one next to each other, what do you give more? So it's funny to see that it came out from real estate who ask us, well, I want to put a city block or some buildings or retrofit, but I want to make it more appealing than my neighbor. What can I do? So we propose them, okay, why don't we go to completely CO2 neutral and even beyond? Can we be off-grid? Is it possible? So that's the idea. But one of the particular things is when you go into this passive house building, you start working with what we call data-driven architecture. It means driven by tools, software that we steal out from engineers and use it as architects to make new narratives. So all this loop, this kind of iterative loops of tools, it's really to predict how these buildings are going to behave, and it also can help to shape or to lay out or to design this building based on solar radiation or sunlight or heating, etc., overheating. So what I'm going to show you is also a reason why passive house became the code in our country is also because one project of two has been done and completed for a lower cost than business as usual. I know that normally it's supposed to be more expensive, 10, 15, 20% maybe. It's not always the case. So we had some projects that has achieved passive house, even net zero energy, for a lower cost than classic, which is not that good for us because we are paid on a percentage, so it's a catastrophe. But for the client, it was fantastic. So here you see even on a district scale. So that's a building, it's under construction. We are doing one for the municipality of Vancouver. It's also a passive house, of course, residential and school. This one just start now, the construction. And all these are generated with parametric design, so all this data-driven architecture that help how to make it with a very low cost, very basic, how to use all these tools to make these close to zero energy buildings. These two also, this one, the one on the right is in Luxembourg, the one on the left is almost over. It's in the center of a European neighborhood in Brussels. Again, all generated by parametric design. Same in retrofit. The one here on the left, that's the existing building, is going to be changed into close to 200 housing. The one on the left, you see below how it was before. It's building from the 90s. So we do all kind of retrofit, building from 19th century up to buildings from early 21st century, which is a shame. But okay, fine. And again, the idea was also if you can go beyond. So we did 1 year ago, we put on the market tiny boxes, tiny houses who are completely self-sufficient, not only in energy, but also in water. We wanted just to see if it's possible to live and to be in completely off-grid. So if there is war again or whatever it is, we don't care, because if you live there, you're free of everything. We did also a Belgian embassy. We did two in Belgian embassy actually, and the one in Morocco, it's completely off-grid. And since 2 years now, We hear nothing from the ambassador, so we guess it's working. But it was the very first embassy in the world to be completely off-grid, because passive house, come on, it's too easy, it's too cheap, it's too easy to do. So the idea is to go beyond. So now, on a larger, on a brighter scale, what we try to do is projects who are not going just to be self-sufficient, water, energy. Water actually is very tricky, energy it's too easy, but also try to have a global assessment who achieve the CO2 neutrality. And for that we use the one coming from England. It's the PAS 2050 and 2060, where you can calculate even existing material, embodied energy, etc., and you convert everything into a CO2 equivalent. So the one on the left is a huge project of retrofitting in Midtown in New York. The one on the right, it's another project completely crazy. It's a Luxembourg developer who want to make a small district in Arizona. So this is why we're in the desert, and you want to put 400 houses in the market at the same cost than a classic stupid house nearby, but to be completely self-sufficient in energy and in water. Of course, we said yes. We're still a bit struggling how to make it for the same cost than business as usual. But again, otherwise it would be too easy. Again, in retrofit, the one on the left, it's a building from a huge insurance company in Paris. It's called Covea. And the nice thing is, since last year, we have, end of last year, beginning of this year, we have the taxonomy would start, where the big groups going to have to declare all the assets that they're going to have, and also where they're going to invest. And there's a kind of panic for all the huge real estate. How are their existing assets going to be? How it's going to be the tax based on the CO2? And we know that it's going to happen for all of us in Europe by 2030. So we're going to have to pay not only for taxes based on what we earn, but also what is our impact. So the idea was here, when the client asked us, can we do a CO2 neutral retrofit of a former office building? We said, yeah, come on, that's too easy. Why don't you put a retrofit of that building, 2/3 offices and 1/3 housing, into a completely, of course, CO2 neutral, but €0, £0 on the bill that you don't pay anymore. And that's very easy when you have such a mixed use. This one is another project. It's running. It's in France. It's a university. It's 25,000 meters square. It's in renovation while it's busy. So the people didn't quit the university, but while they're busy, we retrofit it. And again, we use parametric design to help to shape the new envelope. This one is another project to start in Luxembourg. PVC is the new landlord of this building. It's a development, and again, they were considering staying in where they are now in their headquarters or going for a completely new CO2 neutral. It's the first in the market in Luxembourg. We just started now. It was a huge competition. And also the reuse. Reuse was like something funny, and why not? We can reuse already everything, like the carpet, dry walls, and etc. But in structure, it's not yet done. So here, last year, we had some project who started in the middle of the war, at the end of the sanitary crisis, and there was a lack of steel. Steel was like 250% the steel cost. Aluminium is the same, copper, etc. So there was a lack of steel in Belgium, north of France, south of Holland. So one of our builders were to go in old stock of former steel to reuse it, and we are doing now one of the very first projects who is doing reuse, and the steel there cost like 45% compared to new steel coming from ArcelorMittal. And it was not just for the planet, it's just for economic reason. So the one, it's under construction. The one on the right, we're going to use the same structural beams and so on to reclad, retrofit again a former office building into close to 200 apartments. Of course, CO2 neutral, €0 on the bill. Otherwise, it's not that funny. I'm going to show you this one to end. Well, before ending, this is a huge building. It's a landmark. It's a listed building, as we say here. So it's a building from the 60s, coming from Skidmore, Owings and Merrill, A2M, one of the star architects in the world. And the bank is ING Bank. And ING Bank made competition, and they said 2 years ago, we need to retrofit that building which is 60 years old, and that's all. That's it. There are close to 3,000 people working there, and we propose them, why don't you go to with the same shape, the same design, keeping the same look? It's listed, it's landmark, but why don't we go to CO2 neutral? And they say, yeah, just go for it. We will see. In the meantime, that taxonomy, as I said, came into effect, the new law, European law, and in the meantime, with the war and just before Putin came in Ukraine, gas was already rising, and we calculate back in the days that savings, while this one is going to be overachieved, the renovation, we're going to save close to 1 million euro a year. And now, just thanks to Putin and gas costs and so on, it's 3 million that they're going to save. Just because we decide, why don't we go to passive house, to zero energy, and to CO2 neutrality? So this one is under construction. Actually, we are completely opening from the inside. Of course, we put triple pane. The thing is, we have now in Belgium triple pane at the same cost than double pane was 10 years ago. So then, of course, it makes it easy. And the construction, well, the renovation of that building, it's just a bit lower than a business as usual retrofit or renovation. So, of course, who would not do it? And the last one is what we call, it's also parametric design. We start doing now what we call modular construction. Well, I don't know. Yeah. So we use these parametric tools to play with algorithm when we put some rules that when we do shapes or volume, if you have a small district, why don't we simplify everything to a modules of, I don't know, 3 meters by 3, 3.5 by 3.5. It's parametric, so it's very easy to play with. And that generates a best case for how to make duplex or simplex. We can put any rules we want. And then it generates automatically all the minimum elements that has to be prefabricated off-site. And then the idea is to bring it on-site, a bit like lean management, to reduce to a third the construction period. And with this one, that's one of the first projects we start with that. We're going to have only 5 wall components. It's completely dry wall. It means you can reuse every element. We call that also long life design. It means between floors you can remove slabs without need to reinforce them. And this is how it should be in the future because we have a lack of materials. So the idea is also to just not be CO2 neutral or zero energy on a bill, of course, but to go just a bit further, that everything you build, actually you build a future bank of material. Voilà. Thank you.
Thank you very much. Some really interesting lessons there, I think. One thing I'm taking away, everything built to passive house. We are quite a way away from that in this country at the moment. Okay, we've got a bit of time for questions. So, can I see a show of hands for anyone with a question? Yes, gentlemen, just here.
Hi. Yeah, it was really interesting. I loved your comment about the fact that the passive house was, the building was cheaper than business as usual.
Exact.
And it obviously made me think that you must have maintained a good design through the delivery process. Was it a different contract type, or was it driven by the client, or were you more engaged all the way through?
Yeah. First, one of the reasons, it was a surprise for us because when we discovered passive house, it was in the early 2000, 2003, 2005 in Germany. And they told us there, look, if it's good for the planet, you have to suffer. It has to be just a little bit more expensive, but it's good for the planet. In Belgium, we're not exactly like that. We don't like to suffer. Actually, no one would like that. And when we did some buildings in design and build together with builder, we discover actually that sometimes when you listen to the worker or the subcontractors, they have even better ideas than us. And when we explain what was all about in building physics, actually, they show us tips and tricks. And this is how, step by step, some of these buildings became a bit cheaper just by listening a carpenter or a masonry. So this is how it all happened. And since then now we have a lot of this design and build, and sometimes design, build and finance. So the builder also bring the money to pre-invest and he recuperates the building when it's completed. And this is how we discover so many tips and tricks that we had no clue idea it was possible. Now when we do trainings, we show these tips and tricks, of course. And basically, yeah, it's very stupid. My grandmother can say it. You just have sometimes just to listen just to each other because So it's very stupid. So, and you don't have to change everything. Compare of what we heard back in 2000 and something, again in Germany. We love Germans, don't misunderstand me. It was, yeah, but you have to change everything, you have to train everyone, but that's not possible. When the law came to effect in our country, you could not train 30,000 workers. It's not possible in 4 years. You could not train 11,000 architects. There's no way. So, and it's the same when we went to Portugal, to Luxembourg, or to New York, to California, to Arizona or Vancouver. You cannot train everyone. But what you can do is just sit and listen. So there we just listen how you build, how you good at. Are you good at dry construction or massive construction, pour concrete, whatever? And we just adapt the way you do just a bit, not too much. So that's a very stupid trick, and then it's possible to make it at the same cost or sometimes a bit cheaper. You just have to sit together.
Great, thank you, Sebastian. I think there's some really pertinent lessons there, and I'm sure if you want to catch Sebastian for a little chat, he'll be around for a couple of minutes afterwards. But please join me in thanking Sebastian for his presentation. Thank you. Thank you, ladies and gentlemen. Okay, we're going to kick off with our fourth and final presentation of this session. So now we're going to look at the integration of low carbon technologies into the domestic home. So I'm now going to hand over to Christian from Viessmann, who is going to speak to you for the next 20 minutes. Over to you, Christian.
Yeah, good afternoon. I hope you can hear me all right. I'm standing around there, so there's lots of background noise. So let's see how we're getting on. So yeah, Christian Engelke from Viessmann. I'm the technical director, and I'm going to present you some potential vision solutions for future homes going into the electrification. We will have some exciting technology mix. Let me start first of all with the context where we are coming from, and I don't want to obviously explain the obvious because we all have a bit of a view about how the world is going mad, etc., and whether it's all linked to climate change and so on. But obviously we all know that the discussion with the government is to limit the temperature increase of the climate, and people are saying now 2 degrees is maybe a bit too much. We have to reduce it to 1.5 degrees. But I think in our context, in our world, as a manufacturer of heating products, energy solutions, etc., we are very much conscious from the company point of view to provide the right solution to households and our businesses. But also we have to think about our generations, our children's and grandchildren's to come, that they have got a space to live. And it's a very much an obligation and a responsibility of a manufacturer like us to provide the right solutions and play with the game. So reducing CO2, naturally, as you would know, with the energy crisis, the war in Russia and Ukraine has obviously accelerated our transition to reduce CO2 significantly and remove fossil fuel. And it's a conflict we currently have between reducing fossil fuel but also reducing our energy cost, and that is something which we have to get right. We hear it all the time that obviously, you know, the bills are very close to our pocket and our earnings. Living cost has increased, but on the other hand, we need to have that vision in our head and our games to reduce our fossil fuel exposure and look for energy-friendly technologies. We all know what potentially the climate change will do. You've seen that in newspapers, everybody's talking about it, what 1.5 degree will do to us, 2 degree. I think only today or yesterday, the paper was saying that obviously half of Britain will be flooded if the temperature goes up by 1.5 degree. So I think the low-level coastal regions will suffer if this is going ahead. But as I said, everybody will have their own view on this. The government, obviously a couple of years ago, has set out a 10-point plan how to tackle it. And the good thing from the British government also, they were one of the first industrial nations to put a law out there to reduce, to get to that net zero carbon. Here is just an extract of all the plans they had to do in terms of offshore wind and delivering nuclear power, etc. But also from greener buildings, which is obviously our heart, and we're talking about it later on today. Net heat in buildings, net zero carbon strategy is again very much our goal now, and as a manufacturer we have to find the right solutions to submit to these buildings to make sure that we're achieving the goals. The government targets where that all heat needs to be decarbonized, so get rid of fossil fuel. The promise that it will create 250,000 of jobs by 2035, reducing the cost of heat pumps, and we all know people are installing heat pumps. It's much more expensive, and reducing about 25-50% is a government target as well. They want to be parity with gas boilers by 2030. So that's a challenge, obviously, not only for the manufacturers of heat pumps, but also for the whole trade to make that happening. We need to also talk about the moving away from fossil fuel boilers, as I said before. That's, again, a very, very strong challenge, especially in the UK, where 90% of all fuel supplied to homes is gas. Gas is something which we've enjoyed and lived with. We found it safe, secure, and get rid of it. A reliable energy source is the biggest challenge. And you've seen it also, installing 600,000 heat pumps a year by 2028. Currently, we are running short of this target. I think last year we've installed probably 52,000 heat pumps. The target in the next 3 years to do 600,000 a year is a tall order, and we all have to come up with some solutions. However, what will change in the household system, and that's coming across obviously this winter very much. This is an example here of a typical British home with energy requirements. We have here 12,000 kilowatt hours of gas consumption and 2,900 kilowatt hours of electricity. To make all this electrification work, we have to move them from gas boilers to heat pump. It will change the homeowners' energy bills as well, pretty much. So gas will be reduced to a minimum, hardly anything, certainly if it's just for heating. Electricity will go up by 6,000 to 6,500 kilowatt hours on average, an increase of 124%. Installing a heat pump with PV system, which is obviously what we're trying to do, will reduce your energy exposure again by nearly 30%. And then the next bit is the battery storage, which you've seen here in this exhibition as well. So all this looks very nice and very simple by doing it. Cost deliberately not mentioned in here, because you can all do your maths yourself, saying that electricity is so expensive now compared to gas, it doesn't really help me going this. But nevertheless, it's a different subject. Decarbonising is going electric, but this gives you an example really how the energy bills of domestic homes will change on average. Looking at electric charging points, again, lots of people here on the stand to sell electric charging points here will change your electricity bill even further. So with the heat pump and the electric charging points, if you have an electric car, charging up your car yourself, electricity will go up to nearly 11,000 kilowatt hours. Multiplying that with your electricity cost will be a significant bike. Again, you need to reduce it, adding PV to it. The PV example here in this calculation is based on 3 to 4 kilowatt installed PV system. And again, the next bit to reduce your electricity consumption is with a storage system, which reduces another 12%. So this is, again, something which we all want to do as a solution, as a business, but how do we do it? Now, the ideal scenario is that the whole heating system in your house will be all based on electric. So electric heating, electric hot water, you're generating electricity with PV, you're managing your cost through import, export, and this basically a summary how this energy consumption will change. Of course, we hope that the electricity cost will reduce as well to make this as a benefit to yourself. But the challenge we all have is to manage your home systems. And that comes to the Viessmann solution, and what we're trying to incorporate with our technology is a home energy management system, HEMS in short. And what we're trying to do with the solution is giving the customer a transparency of their energy usage, transparency of the cost efficiency, transparency of the independence and sustainability. HEMS, in short, was predominantly used in the commercial world, but now we see more and more systems appearing in the residential aspect as well. And this is where Viessmann can help you with the right solution and the right exposure. What we all want to do is naturally reduce the cost of your safe, and combining these different technologies now, it becomes with electric very simple, and it's so important that we are killing off the energy wasters, we are reducing the CO2 in fossil fuel, and we are also want to make sure that the system is optimized in the right way. Energy management system, certainly from Viessmann's point of view, has been in existence for a few years. We started off with the first lot there where PV and heat pump can be easily electronically incorporated. It was sort of the first stage of our heat pump systems and controllers to communicate with the PV system, and where PV system is activating the heat pump operation to make sure the best is done. Now the next stage is battery storage. Battery storage is becoming more important because obviously you don't want to waste or send energy companies your free electricity. You paid very heavily on your PV systems. So battery storage becomes very important for optimization. However, it doesn't give you the full benefit in terms of usage and optimization, because the systems do not control with each other. And then the next stage, the final stage from Viessmann's side of it, the full optimization with the systems we have based on the one base control platform we're offering on our heat pump controllers, our battery storage systems, wall boxes, etc., and also the ability to connect to any third-party inverters if you have already a PV system from other companies there. So again, these are the three stages of the evolution. So with the first one obviously being about 20 years old already, and we are now sort of in this transition period here between the last two concepts. So the vision from Viessmann's point of view is obviously that we want to make sure that all your electricity generation from PV is utilized in your own house. You don't want to give anything away to your energy companies. You don't get any money from them. I think the smart export guarantee will give you maybe 6p for exporting electricity, but you're buying it back for about 40 pence today. So Viessmann's solution, energy management inside Viessmann One Base. The One Base is our description of our control system there, which we've applied to our different heat generator technologies. This is, for example, an example how it could look like your future home. We have a heat pump system there, we have a battery storage system, they're all linked to the energy management system. The energy management system in this case is free because it's embedded in our vCare app, in vGuide system for the installer, and for the end user, you have got all the monitoring capabilities there. We can also look at combining it with third-party controls. We have a data logger there for reading third-party inverters if you have to. But the important is that there are certain components like a heat pump and a battery storage system are a Viessmann controller, and the homeowner will have the advantage. Then he will have the energy management side of it and optimization all from one hand. Again, our motivation was that we want to go towards 100% self-consumption. We want to use it and make sure that you're not wasting anything. With wall boxes, battery, PV, everything is available, and we want to maximizing your system and saving the most important, you're saving your energy consumption from that point. So 100% self-consumption, very important, so you're not wasting anything. Benefits from the end user point of view is obviously he will have everything on the app. He can monitor his performances, transparency, as we said early on. He can check his CO2 balance, life energy, etc. Combining it with cost of the grid, electricity, etc. to optimize the operations possible. Everything is available on the hand. Our installation partners will have the benefit also that they can obviously monitor his customer performance. He can agree a service site visit to optimize the system to work it better. Everything is available mobile, and it gives them all the right tools to support the end user with the right knowledge and the right equipment. For us, biggest challenge is naturally that the opportunities are endless. And I said before, with moving to electrification, it gives us huge opportunities to control everything from one system. In the past, we had oil boilers, we had gas boilers, we had a bit of electric here and there. It was difficult to do. Now, with this technology we're putting together, electricity, etc., enables us to monitor and optimize the system for the end user. Thirdly, also is the third-party integration. And again, that's the next stage we're trying to do, to finding the right equipment and the tools cost-effectively for people who already got a PV system, a battery storage perhaps, to then integrate it into our one-base control platform to enable them to monitor the systems. Again, monitoring for us a very important subject. Energy cockpit, sustainability. And I tell you, it's a nice talking point in the pub. You can brag to your friends in the pub, telling about how much energy they're saving, how much money they're saving, how much they're generating, etc. You can remotely turn certain things off. You get maybe the complaint from your wife or whatever, the kids, that the hot water is off or heating is off, etc. But anyway, it's becoming so important now that homeowners want to be in charge of the whole system, and this is what we are offering to our customers. Finally, self-consumption optimization. It is a real challenge for manufacturers to find the right control algorithm to control heat pumps with PV and battery storage, because historically heat pump is purchased from a company, PV from a different company with an inverter from another one again, battery storage from another business. The control system in the house are again run maybe from a fifth or sixth supplier. Optimization becomes then a real challenge. You have to go to third-party control manufacturers to design something for you. Again, that will be then an additional cost. In our world, we are trying to then optimize the system. This is just give you some examples what we're trying to do with the optimization, to use the heat pump on the right-hand side at times when solar PV is, for example, being used. You don't really want to run the heat pump in the battery at times when PV is generating. And ironically, PV generates power mainly in daytime, which you don't really need much heating at all, or hot water. And then at night when the heating kicks in and hot water kicks in, then the PV is not generating anymore. So that optimization to ensure that all your electricity you're generating from PV is utilized in the best way possible is for all manufacturers a challenge. We have the solution, we think we have got the solution, very cost effective for end users. So that's sort of sums it up. And finally, I was going to show you a short 1-minute clip to summarize all this, what I've just explained to you. And hopefully you will be as satisfied as we are with the outcome.
These days, we all want to live as climate neutrally as possible and keep our carbon footprint as small as we can for the benefit of future generations. This is only possible if we work together. By connecting our technologies, our climate and energy solutions can have a greater impact. Better together. Our heat pumps use the free ambient air or geothermal energy. And the electricity with which the heat pump is powered comes from the sun. Surplus solar energy is stored and can be used later or fed into the grid as 100% sustainable electricity. Our heating systems are more reliable and efficient than ever. They have more power with less consumption. But the biggest advance is that they can now be a part of a completely connected home system, digitally integrated into one unit. Our systems achieve their maximum efficiency and sustainability with maximum comfort. And because the system can be controlled remotely, whether you are an end user or a trade partner, we have the right app for your needs. Remote maintenance saves time and money and is better for the environment at the same time. This is how climate and energy solutions are created. Holistic systems are modular and fully integrated. You can start with one product and expand your system at any time. We are here to help you become part of a great movement. We have the power to act now for ourselves and all who come after. We design living spaces for future generations. Viessmann.
Right, so that was it for me today. I hope it wasn't too bad for an afternoon slot. So you can go home and watch a bit of telly as well. Fortunately, it was Viessmann telly, so, but yes. So I'm finished now, so I think question, if you have, just raise your hands.
Yeah, thanks, Christian. Probably got time for one question before the next session. Is there anybody with a burning question? If not, I'm sure you can grab Christian afterwards, because I noticed there were a lot of pictures being taken, so I think people have taken a lot in there. Okay, if there isn't one, would you just join me in thanking Christian for his time this afternoon? And that's it for our session. So thank you very much for joining us here at the Future Innovation Stage. I hope you found it useful and some good takeaways, and I hope you have a good rest of the show. Thank you.